Okay, here is problem number 5 on section 9.5. This is a little tough. It's a bootstrapping problem where they give you the sample, but instead of generating samples ourselves, um, they give us a table of samples that they've made, 200 different samples. So we're going to click the icon to open the Bootstrap Samples box. And it takes a minute because it's 200 samples. And we're going to construct a confidence interval. A bootstrap confidence interval. Okay, now here are all the different samples you see. It goes on and on, all the way up to 200. And here are the different values. Now we can open this in StatCrunch. And usually what we want to do is we want to get the mean. Well, we want to get the mean of all these samples, but usually the samples are arranged in columns instead of in rows. So what you're going to actually have to do to be able to get the mean of all these different things is to transpose the data. If you go down to a range here, you transpose it, you can turn the rows into columns. And you just select all of them. And I say open in a new data table. And it's like, whoa, you got 200 columns, that's a lot. But you still hit continue. Okay, and now you can see each column here, these are just labels, but each column here is one of those samples. Okay, so now what we want to do is we want to find the mean of each sample. So we go to stats, summary stats. The samples are in columns, and we want to do this for 1 all the way to 200, right? And do that for the mean. We want the mean of all those. And we want it to store in the data table. And we just hit compute. Okay. So now we got 2 columns added onto the end of our table here. One is the sample number. So this is the first sample, and this is the mean. This is the second, and this is its mean. Okay. Now, of course, what we want to do to get that confidence interval is we want to do the mean of the means, right? We want to find the mean of the means, and we want to, since this is we got a lot of little windows open here. So I think it's 95, 95% confidence interval. We're doing the 2.5 percentile and the 97.5 percentile. If it was 10%, if it was 90% confidence interval, we do the 5% and the 95%. So let me go back over to my table here, and we're going to find the mean of the means. Again, it's in columns. This time I just want mean, right? That's the label of this. And I want to find the mean of the means. And here's where I can insert the percentiles. So this is what 2.5 comma 97.5. And here we just compute. Okay, so here's the mean of the means, like 4.9. And then the 2.5th percentile would be 4.74 if we're rounding to 2 places. And the 97th would be 5.1 if we're rounding to 2 places. So I'm just going to go back into my, so I can close all this stuff so I can answer the question. What did I say? 4.74. And then I remember this one's 5.1. Let's hopefully I remember that right. Okay, so that's our confidence interval. And then the bootstrap interval is, and we have choices, narrower, the same as, or wider. And we know it's always narrower than the t interval would be. Okay. And we're asked to draw a histogram of the 200 samples. So we just go back to the table. And I just want to do a graph. And here I'm going to do it of the means. Right, this is my sampling distribution. My bootstrap sample distribution. So mean, that's the column, is named mean, and you don't have to worry about what you want to group it by. I just do a frequency one, and I think I just hit compute. Let's see if it gives me a nice histogram. Yeah, okay. So here it gives me a nice histogram. Again, the mean of that distribution is about 4.9. And there's a little bit of stuff off to the right. But of the four pictures, right, clearly this is the one that's looks most like my histogram. Okay. And the histogram is, we get a trough of roughly symmetric, bimodal, right skewed, uniform, or left skewed. The only thing I would be tempted to guess between is roughly symmetric or right skewed. It's a little bit more on the right, but overall I'd say roughly symmetric. If I didn't get this one right, I would then answer right skewed. Sometimes it's a little bit of a tough call between those two in this particular circumstance. Oh, but I got it right. Okay. So that's how to do number 5. I hope that helps a little bit. The toughest thing is just transposing the data so that then you can find the means. Hope that helped.